November 1941. Kummersdorf Proving Ground, Germany. In a drafty hall south of Berlin, under yellow lamps that made everything look the color of old metal, German engineers walked slow circles around a captured Soviet T-34. They had pulled the side skirts off, chalked measurements on the glacis, and set calipers on the floor beside a stack of cut armor coupons. The tank still smelled of warm diesel and wet mud, even though it had been pressure-washed twice. An ordnance officer from YPRF Lu read out angles while a draftsman traced the silhouette onto brown paper. The thesis emerged before the wrenches were even warm in their hands. Against the design assumptions of the Panzerwaffe in 1941, this tank broke the rules. Its armor was thinner than a Panzer IV's on paper, but angled so aggressively that German armor-piercing rounds glanced off at ranges where doctrine said they should bite. Its tracks were so wide that even November Marsh turned from enemy to ally. Its engine was a light alloy diesel that shrugged at dust and cold with a torque curve their petrol Maybachs could not match. By the time the turret crane took a first strain, the quiet conclusion was already moving from the floor to the reports. If this was the Red Army's new standard, then German tanks, built to pre-war logic, were obsolete the day they met it. The floor team began with what they could see. The upper glacis of the early production T-34 measured about 45 millimeters in thickness, but the plate was laid back at roughly 60 degrees from vertical, through simple trigonometry that gave an effective line-of-sight thickness approaching 90 millimeters and added a deflecting component to the impact of incoming shot. In practice, that meant a German 50 millimeters gun standard on the Panzer. The third struggled badly at ordinary combat ranges, and short-barrel 75 millimeters rounds from early Panzer IVs lost velocity and penetration too quickly to be decisive. The proof had already come on the road from Smolensk, where crews reported clean ricochet scars like fingernail crescents on Soviet hulls. The scars were catalogued one by one and compared to the firing tables in binders that still smelled of paste and glue. The numbers lined up. The assumptions did not. They moved to the running gear. The T-34's tracks were nearly half a meter wide, roughly a third wider than those under many German chassis than in frontline service, spreading weight over a bigger footprint. On the proving ground's sandy soils, the German testing drivers found the T-34 reached and sustained speeds in the high 30s of kilometers per hour cross-country, while their own familiar machines bogged sooner and chewed deeper ruts. Some of that came from weight, some from gearing, but much came from the combination of a torquey V2 diesel of around 500 horsepower and a suspension born of the American engineer J. Walter Christie's ideas, adapted by Soviet factories into tall road wheels with generous travel. To the engineer's ears, the suspension sounded rough. The gearbox felt agricultural, with a first gear so stiff that Soviet crews learned to start off in second, and the steering clutches demanded a farmhand's shoulders. Yet the test drivers kept returning with the same verdict. Once in motion, it flowed over ground that punished Panzer tracks. They cut samples from the hull and turret and sent them to metallurgists. The steel's composition was not exotic. The welds were sometimes untidy. Cast components showed inclusions that would have made a German shop foreman reach for a reprimand form. But the Soviet choices had an internal logic aligned to mass production under pressure. Big castings cut labor steps. Sloped plates did double duty, saving weight for a given protective effect. The turret ring diameter supported a 76.2 mm gun that, at typical fighting ranges on the Eastern Front, could hold German armor with a flatness and energy that surprised even confident test officers. On paper, many of these attributes had been known in pieces from pre-war foreign reports. Seen together, under the same lights and on the same scales, they formed a system. That was the shock. The German design tradition that led into 1941 favored vertical armor that was straightforward. To machine and assemble, fine tolerances that kept drivetrains smooth, and compartment layouts that made maintenance logical by workshop standards. It prized good optics and comfortable gunnery. The T-34 turned those preferences into liabilities. A vision block chipped by a glancing round mattered less if the round bounced in the first place. A beautifully machined gearbox lost the argument if the tank never reached the fight because of mud. The Soviet turret was cramped, crude to some eyes, and its two-man crew arrangement overloaded the commander with gunnery tasks. Yet the gun he served hit hard enough and early enough that crew inefficiency could sometimes be paid down with shock at first contact. Doctrine flowed from these sums. Soviet formations used speed and shock to close, accepted losses at the spearhead, and trusted sheer numbers and simple serviceability to keep momentum. German doctrine had expected to choose the terms of battle with radios, initiative, and superior tactical handling. On fields where a battery of T-34s appeared, those terms shifted. Reports in the winter of 1941 from Army Groups Center and T-O. South had already stacked up with patterns that were hard to misread. Engagement narratives began to contain ranges where German commanders told their gunners to hold fire until side angles opened, or to aim at the lower hull where angles flattened. Requests for more powerful anti-tank guns picked up in tempo. Photographs of knocked-out Panzers with soot-lip holes through mantlets and center glacis plates sat like punctuation on the desks of officials who had believed weight of fire and crew drill would continue to cover deficits. The Kummersdorf teardown gave these impressions a technical backbone. Armor profiles were plotted. Angles were annotated for ricochet probability bands. Penetration curves for the 76 2mm F-34 gun crossed thresholds at distances that mattered in the east, where sightlines could run long across open fields in one sector and compress two hedgerows of scrub and birch in the next. The field and the factory were now in the same conversation. Production logic was the next skepticism to fall. German planners stepped into the T-34's hull and traced how a factory worker would reach the welds. They counted the parts in the crested arrive suspension and compared the count to boogie assemblies on their own vehicles. They weighed the labor hours that steel castings saved, then weighed them again against the shortages Germany faced in alloys and foundry capacity. The Soviets had moved factories by rail, hundreds of kilometers east, and still managed to turn out thousands of tanks, month after month. A rough but telling metric from 1942 put Soviet T-34 output in 5 figures for the year, averaging on the order of 1,000 units per month across peaks and troughs, even allowing for repair returns and training allocations. That cadence meant the Red Army could reconstitute armored brigades at a rate German industry could not match. The teardown team could read those numbers in the metal in front of them. It was a tank you could build in a hurry and repair in a hurry, then throw back into battle before the offense died of calendar. None of this erased the T-34's flaws. The optics were inferior to German glass, which meant hits at longer ranges were less certain, especially when dust and exhaust haze hung low. The two-man turret cut situational awareness at the moment when it mattered. Early turret hatches were heavy and slow to clear in emergencies. Gearboxes had a short life if mishandled. Fit and finish varied wildly from factory to factory, a function of wartime conditions and uneven worker training. Yet, the teardown team kept returning to the basic equation, because war is always equations disguised as choices. If your tank survives the first hit because its angles and thickness defeat a standard enemy round at 500 meters, and if your gun penetrates his front at the same distance, then your crew can afford to fight with imperfect glass and cramped shoulders. If you can produce 10 of these for the labor cost and materials of 6 refined machines, and if your railways can carry them to the front at that rate, then your army can afford to learn under fire. That was the uneasy insight on the Kummersdorf floor. As the winter of 1941 turned to 1942, the debate inside German armored design circles sharpened. Some argued for incremental thickening and upgunning of the existing Panzer IV platform, which was robust and mechanically honest. Others insisted that a clean-sheet answer was required, one that took the T-34's core logic and answered it with German metallurgy and optics. The driving requirements that emerged inside the Heereswaffenamt read like a mirror held to the Soviet machine. Sloped frontal armor to defeat the 76.2 mm at practical ranges. A new long-barrel 75 mm gun capable of defeating the T-34's glacis at ranges where German gunners preferred to fight. wider tracks to bring ground pressure down and mobility up. A more powerful engine married to a suspension that could keep pace cross-country without beating itself to pieces. If these lines sound familiar, it is because they are the skeleton of the vehicle that would become the Panzer Kampfwagen V Panther. Before those lines hardened into production orders, the tearing down continued. Engineers weighed whether to emphasize casting, as the Soviets had, or to keep plates and welds in the German style. They measured turret ring diameters and made room for recoil length on longer guns. They sketched interleaved road wheels to spread load and improve ride, aware they would complicate maintenance when mud froze around the axles. They thought about field stripping in January and rebuilding final drives in March. They walked the route that spare parts would take, from a factory in the Ruhr through marshalling yards that British night bombers now knew by heart. On the Kummersdorf floor, the T-34 was not just a machine. It was a curriculum. Across the front, that curriculum wrote itself in casualty returns. In the first summer of the invasion, Panzer units had often punched through Soviet lines by tempo, communication, and tactical flexibility, isolating and reducing pockets while infantry closed up. When T-34s and heavier KV series tanks began to appear in concentration, the momentum bled. German units still often prevailed by combined arms and operational art, but the cost in tanks per week rose. A battalion staff officer only needed to count if, in June, a standard formation lost a handful of vehicles to mechanical attrition and enemy fire in a week, and in October, that handful turned to a dozen. Then doctrine needed an answer in steel. Requests for more long-barrel 75mm guns mounted on Panzer IVs arrived with an urgency that read clearly, even when the prose was guarded. The Kummersdorf notes quietly confirmed what the combat logs said aloud. The existing fleet could not carry the war alone into a second summer. There was another layer. The T-34 embodied not just an engineering choice, but an industrial philosophy. It gave the Red Army a tank that accepted roughness to gain output and battlefield survivability now, rather than perfection later. German engineers could see the difference in the textures of the welds and the fit of the hatches. This was not a mark of inferiority. It was a mark of priorities under invasion. The tear-down team could not change the fact that German factories stood under increasing air attack and depended on raw materials. That came through bottlenecks that grew narrower with each month. They could change a drawing. They could change a standard. They could write a new technical requirement. To admit the T-34's logic was to admit that the production race mattered as much as the next tactical gambit. In that sense, the most important thing dismantled at Kummersdorf was not a tank, but a prejudice. By early 1942, the official memoranda began to sound like the engineers' conversations on the shop floor. Sloped armor was no longer an experimental curiosity. It was a baseline requirement. The new gun would be long and high velocity. The breech-sized 2 fire armor-piercing rounds, designed with the T-34's glacis in mind. Turret ergonomics would be addressed with a 3-man crew that freed the commander to command. Track width would move toward the Soviet example, and suspension travel would increase to keep pace cross-country. The paradox sat in the margins of those same pages. Each of those improvements increased complexity or weight, or both. At the same time, the strategic situation demanded numbers. The document trail captured the strain between engineering ideal and industrial reality. In field shops from Vyazma to Kharkiv, frontline German mechanics made their own small reconciliations. They welded jerrycan racks and spare track sections to holes to serve as impromptu standoff armor. They learned the angles at which a Panzer III should bait a T-34 into exposing a side. They integrated towed 75mm anti-tank guns tighter with their maneuver units and coordinated better with Stuka, dive bombers and artillery for the moments when tanks alone could not pry a position open. Those adaptations kept formations effective. They did not erase the basic trend line unveiled on the Kummersdorf floor. Head-to-head at typical Eastern Front distances and terrain, the T-34 redefined what standard meant. When the engineers finally lifted the turret free and set it on a timber cradle, there was a moment that could have passed for ceremony if anyone had let it. The ring bearings were measured and set aside. The gun cradle was weighed. The mantlet came off with a groan that echoed off the concrete. The men in grey coveralls had done this 100 times with their own machinery. They knew the feel of German steel through the palms of their gloves. This felt different, not because it was better in every respect, but because it was better in the respects that war in the East demanded. The lesson on the floor and in the reports was blunt. The Panzerwaffe could still win battles. It could not win the war on the schedule, and with the machines it had taken to the frontier in June, the rest of the winter and spring, converted those lessons into designs and orders that would shape the next 2 years. The new tank that would carry the German answer would not reach the front in numbers for many months. In the meantime, upgraded Panzer IVs with long 75mm guns filled the gap, restoring reach and lethality at ranges where the pendulum had swung the Soviets' way. Even there, the teardown's fingerprints were visible. German gunners were given range cards with new figures that took sloped armor into account. Commanders briefed their companies on aiming points that factored in deflection. Training salaries shifted to emphasize rapid flank maneuvers and combined anti-tank packages for meeting engagements with T-34 heavy formations. The dismantled hull at Kummersdorf had written itself into the Army's daily work. Records vary on the exact pacing of every inspection and meeting. And even in the best archives, the story toggles between precise engineering notations and combat reports that compress chaos into 2 lines. Contemporary accounts and surviving. German evaluations from late 1941 and early 1942 align on the essentials. The T-34's sloped armor and 76.2mm gun changed the tactical math. Its wide tracks and suspension changed the map of where tanks could go at speed. Its diesel, power plant, and production philosophy changed the scale at which those advantages could be deployed. From those sums, the German admission followed. It arrived not with a single theatrical confession, but with a series of technical decisions that each said the same thing in the language of metal. The day the turret came back down onto the hull, and the bolts went in finger-tight for transport, the engineers chalked a last set of arrows on the glacis to guide a lecture. The room smelled again of oil and wet November air. They would ship the T-34 to other test grounds and schools, so that men who had not seen the Eastern Front could see this shape up close. The chalk marks were not just notes. They were a change of mind made visible. By the time the captured hull left Kummersdorf on a flatbed, the German answer had been drafted in outline and stamped with the urgency of a battlefield memorandum. The new medium tank would carry frontal armor sloped so steeply that a Soviet round meeting it at ordinary angles would spend itself in heat and spall rather than burrow. It would mount a long 75mm gun with a muzzle velocity high enough to bite cleanly through a T-34's glacis at the ranges where German crews preferred to fight. It would ride on wider tracks, trade a boulevard-smooth gearbox for one that lived longer under shock, and give the commander back his eyes with a 3-man turret. These were not fashionable gestures. They were direct replies to the cold arithmetic of the winter's teardown. On paper, that reply became the Panzer Kampfwagen V. In steel, it became the Panther. Choosing the vendor meant choosing a philosophy. The competition in early 1942 narrowed to designs from MAN and Daimler-Benz that both wore the new sloped silhouette. The winning proposal, approved in the spring, promised an 80mm glacis, angled at roughly 55 degrees. A geometry that turned a flat thickness into a line of sight. Barrier in the range of 140mm, and added the deflection effects that Kummersdorf's chalk lines had dramatized. The gun was the 7.5 cm KWK-42L70. Long enough to carry a muzzle velocity around 900 meters per second, with armor-piercing shot, flattening trajectories, and extending lethality. The turret was a 3-man design, so the commander could command, the gunner could gun, and the loader could focus on keeping the breech fed under stress. The suspension used interleaved road wheels to spread load, improve ride, and keep the gun stable on the move. The engine was a Maybach HL230, petrol V12 rated at roughly 700 horsepower, coupled to final drives that the design team knew were the strain points but hoped to strengthen in production. On the drawing board, the Panther was what the teardown had implied, a German embrace of the T-34's logic. Recast with German metallurgy and optics. No drawing bears the weight of war without bending. As pilot series rolled off assembly lines in late 1942 and early 1943, the compromises that accompany every wartime program arrived all at once. German foundries were under air attack, rail yards frequently disrupted, and high-grade alloys rationed. Each material note in a Panther's file was a negotiation with reality. The interleaved wheels that gifted ride quality also trapped mud and ice, complicating maintenance when temperatures fell and roads became rutted slush. The long 75mm brought lethality, but demanded a turret shape and ring that added mass and complexity. The glacis was superb, but forced the rest of the hull to carry that strength in weight and volume. With the enemy pressing on three fronts and the homeland beginning to absorb the punishment of strategic bombing, these were not academic debates. Every improvement had an industrial cost that showed up as a delay or a smaller monthly tally. While the new tank moved from drawing to shop floor, the front had to be held with what was available. The stopgap answer was to stretch the Panzer IV's reach. The long 75mm KWK-40 transformed it from an infantry support chassis into a true tank killer at Eastern Front ranges, giving German crews a weapon that could punch T-34 fronts at more favorable angles and chew through sides with confidence. Assault guns like the Stoogie 3, mounting similar long 75mm pieces at lower cost and with a lower silhouette, multiplied where industry could support them. In many sectors through 1942 and into 1943, the majority of Soviet tanks destroyed fell to these guns rather than to tank versus tank duels. The Kummersdorf lesson took one path into a future chassis and another into the doctrine that glued mixed units together more tightly. German reports from brigades that meshed Stoogies, towed anti-tank guns, and maneuver companies recorded kill ratios that steadied formations shaken by the previous autumn's surprises. But the arithmetic of replacements waited behind every tactical success. A battalion could fight its way out of an encirclement this week and find itself short 36 vehicles. Next week, with factories unable to refill its line, as the Red Army did. When the Panther went to war in the summer of 1943, the debut showed both the power of the new concept and the penalty of compressing development in crisis. Records vary by unit and day, but contemporary. German returns from the first week of July reported high rates of mechanical attrition unrelated to enemy fire. Final drives failed under the stress of cross-country marches. Fuel and oil leaks fed engine fires. Two-thirds serviceability on paper drooped to a fraction of that on the line of departure in some formations. Those numbers climbed as field fixes and production improvements filtered forward, and crews who took Panthers into action reported immediate respect for the gun and glacis. But the reputation was set by combat calendars as well as ballistics. A weapon is not only its lethality, it is also its availability when the operation begins. The lesson Kummersdorf had written in chalk about sloped armor and wide tracks made it to the battlefield. The lesson about simplicity took longer to speak. Across the same months, the Soviets did not stand still. The T-34 that had stunned German crews in 1941 had carried a 76.2mm gun in a two-man turret and a hatch arrangement that slowed escape. By late 1943, the T-34-85 began to reach units in strength. It brought a three-man turret with a better commander's position and an 85mm gun that clawed back frontal lethality against new German armor at practical ranges. The Red Army also deepened what the Kummersdorf teardown had implied about production. Despite evacuations, shortages, and battlefield losses, factories west of the Urals and deeper into Siberia sustained a cadence that hovered in the four figures per quarter through the Middle War years. Records vary by plant and month, but the normalized rates make the point cleanly. In 1942 and 1943, when German output of new medium tanks could be counted by the hundreds many months, Soviet T-34 output could often be counted by the thousands per quarter. A design that accepted roughness for speed underwrote that pace, and an operational doctrine that absorbed losses while preserving momentum turned cadence into ground taken. On the line, the Panther earned the respect implied by its geometry. A glacis that could shrug off 76.2 mm hits at hundreds of meters gave crews the moral space to fight methodically. A gun that could drive through a T-34 front, on a good angle, at the same range imposed a psychological debt on opponents. German optics and gunnery training still counted. Engagement reports that noted first-round hits at long range mounted again in units equipped with the new chassis. Yet those advantages arrived with a familiar tail. The running gear demanded meticulous maintenance. Spare parts for the interleaved wheels and final drives clogged supply columns. Recovery and repair cycles for heavy components slowed battalions at exactly the tempo when operations required rapid reconstitution. For every Panther that fought, another might be under repair, and a third might be on a train or a road where winter and bombing could both be enemies. The Kummersdorf lesson had been about what to build. The wider war kept asking a second question about how much and how quickly. Crew accounts on both sides render the duel in human scale. German commanders learned that the greatest threat to a Panther was not frontal assault by a single T-34, but a flanking approach under smoke and dust when the long 75 could not be brought to bear in time. Soviet tankers learned to call down artillery to shock German optics and to use the battlefield's folds to present angles that bought chance for side penetrations. German anti-tank guns waited to complete ambushes that Panthers began. Soviet infantry hunted with anti-tank rifles and shaped charges at close quarters around the tracks and rear decks. No design choice erases the fact that men still had to climb out of burning hulls, and that the difference between an inch of armor and an inch and a half could be the difference between fingers on a hatch lip and hands that never found it. The tear-down that had counted degrees and millimeters became a grind of seconds and meters. And in that grind, the side that could afford to lose more hulls and still keep moving gained a kind of inevitability. Back in the shops, the production figures kept score in a different language. German industry would build on the order of 6,000 Panthers before the war ended, roughly the output of a handful of Soviet months when factories were running hard, even granting the Panthers battlefield overmatch against earlier T-34 variants in a head-on gunnery duel. The structure of the conflict made that advantage a local, temporary thing. When the T-34-85 arrived in scale with better turret ergonomics and a gun that could not match the Panther's penetration but could threaten it from more angles at medium ranges, the duel flattened again, and the larger systems contest resumed its quiet arithmetic. Germany's coal, ore, and transport constraints tightened. Bombing raids cut into foundry and machine tool capacity. Each Panther that rolled out represented more labor hours and more critical materials than a T-34, and Germany had fewer hours and fewer materials to spend. Doctrine tried to compensate. The German army leaned harder into combined arms, integrating assault guns, towed anti-tank guns, artillery, and close air support into defensive systems that turned Soviet spearheads into kill zones when terrain and weather cooperated. Panthers served as mobile fire brigades, counterattacking at moments chosen by regimental and divisional staffs to slice into flanks and roll up penetrations. When these systems worked, they inflicted losses out of proportion to the ground conceded. Reports from the Eastern Front in 1944 described days when a handful of Panthers stiffened a front where companies of older models would have failed. But every day, not chosen by German commanders, was chosen by their opponents. The Red Army's operational method grew in sophistication, masking concentrations, coordinating artillery, and smothering defensive strongpoints with massed fire before committing armor. Where the systems collided, the side with a shorter replacement pipeline for both machines and men still bent the line in its favor. The question that had been implicit at Kummersdorf in 1941 now had its answer written across maps in 1944. If a war will be decided by who can deliver lethality to the point of decision faster and more often, then designs that can be produced in larger numbers under pressure have a structural advantage, even if they concede an edge in single-vehicle performance. This is not a talisman. Inferior tanks cannot simply accumulate until they win. They need crews trained to a minimum standard, doctrine that uses them in ways that turn shock into collapse, and logistics that keep fuel, ammunition, and spare parts moving at the same rhythm. The T-34 and the system that supported it met those thresholds and exceeded them often enough. The Panther and the system that supported it met higher performance thresholds locally, but could not be present often enough in time and space to change the war's larger. The admission the engineers had made quietly in 1941, that pre-war German tanks were obsolete in the face of this new Soviet standard, had grown into a harder recognition about industrial and operational tempo. There is a temptation to turn this into a parable of simple versus complex. The record is subtler. The T-34 was not simple in the sense of crude improvisation. It was a refined compromise that took the Christie suspension's travel, married it to sloped plates and a diesel power plant that made sense for vast distances and variable fuel quality, and accepted cramped ergonomics in exchange for speed of manufacture. Its defects were real and painful to the men who went to war inside it. The Panther was not complex for complexity's sake. It attempted to deliver the Kummersdorf lessons in one package, and did so spectacularly in several dimensions. When it worked, it terrified opponents at range, and allowed German units to fight with a confidence that previous summers had shaken. The trouble was that the war demanded not a handful of terrors, but a sea of adequacy that could be refreshed quarter after quarter. The German system could not feed the Panther's appetite at the scale required, and the price of each air raid on a Ruhr workshop accumulates in the difference between theory and practice. Post-war design lines trace back to these two silhouettes with clarity. Sloped armor ceased to be an argument, and became a default in medium and main battle tank design across nations. Turret, ergonomics, and commander's vision became non-negotiable in Western doctrine. And even in Soviet practice, the move to three-man turrets on the T-3485 marked an institutional concession to the value of a commander who commands rather than aims. Wide tracks and generous suspension travel became prerequisites for cross-country mobility in armies that expected to fight beyond roads. Diesel power plants gained prestige, not because of romance, but because of operating range, fuel, logistics, and survivability. Records vary on how designers in different countries weighted these factors, but the broad adoption pattern runs through the same Kummersdorf equations. Even where torsion bars replaced Christie ideas, or where composite armors replaced rolled and cast steel, the underlying logic remained. Make the first hit less likely to penetrate. Let your gun reach decisively at the ranges your doctrine uses. Build in a way your factories can support under stress. Memory carries its own distortions. The T-34 has been praised and damned in equal measure by veterans whose lives depended on whether a hatch stuck or a round found a seam. The Panther has been mythologized as a perfect predator and criticized as an over-engineered prima donna. The archive asks for modesty. Contemporary German evaluations admit the shock of the first encounters with T-34s in 1941 and the respect for their enduring strengths. Contemporary Soviet reports acknowledge the T-34's weaknesses in crew accommodation and reliability, and record the push to correct them under fire. German technical reports on the Panther are frank about the early mechanical problems and equally clear about the gun's performance and the armor's virtues. Soviet battlefield intelligence memoranda treat the Panther as a priority threat by 1944, even while noting vulnerabilities at flanks and the maintenance burdens that cut availability. From these fragments, a coherent picture emerges. The engineers at Kummersdorf in 1941 were not embellishing when they admitted that the tank in their hall made much of their pre-war fleet obsolete. They were stating a boundary condition that would shape every armored decision for the rest of the war. As the last Panthers covered withdrawals on the Vistula and the last T-34-85s nosed across the Oder toward the bridges that led into Berlin, the distance from that cold hall in November 1941 could be measured not only in kilometers, but in mental ground. A captured machine had forced skilled men to set aside pride and start again from first principles. The replies they drafted were intelligent, brave, and in several respects brilliant. They did not come quickly enough or cheaply enough for the nation that needed them. The Soviet machine they studied married aggressive design choices to a production system that could take punishment and deliver mass. And in the end, that marriage mattered more than the last increment of accuracy through a fine German sight. The teardown at Kummersdorf had not been an exercise in admiration. It had been a rare moment of clarity. The engineers bent over their calipers understood that the future had arrived in the shape of a sloped hull, that their standard rounds could not easily bite. The rest of the war was an attempt to catch up with what the winter's measuring tapes had already recorded. When post-war officers taught armored doctrine to recruits who had never seen a battlefield, they still traced a chalk line on a board to show why. Angles mattered more than inches, and why a commander's cupola was not a luxury. They still held up photographs of two silhouettes and asked students to explain which would win at 500 meters on a muddy field and why. The answers were not romantic. They were tables and ranges and simple geometry. The same grammar the Kummersdorf team had used with metal on the floor. That is the quiet legacy of that winter. Faced with the fact that embarrassed pride, the men who built Germany's tanks did what engineers do at their best. They changed their minds, they changed their designs, and they told the truth in their reports, even when the truth hurt. The war around them would punish the delay and the complexity. The craft they practiced, stripped of banners and songs, would remember the lesson and carry it forward. As we approach the end of our remembrance today, we're grateful you listened to this full story with us, and we're glad our archive has nourished your heart and soul. War stories have probably also marked your family's life in some way, haven't they? Maybe you wore the uniform yourself, or perhaps someone you loved did. Your father, a grandfather, or even an uncle. If so, we'd like to invite you to add another chapter to this record. Share with our community a war story that resonates in your family in the comments below. It could be a family tale, a saved letter, a lesson learned on a flight line, or in a muddy field. Anything you want. Tell us from where and what time are you listening to this message. This contribution helps to grow and keep our community together. We can't let these incredible stories be lost in time. The World War II Archives channel was created to honor and preserve these memories. Finally, if this resonates with you, we invite you to subscribe and perhaps share it with a friend who also recognizes the importance of these tales. Stay tuned so you don't miss the next one of our lost archives yet to come.